So students, today what we are going to see is, we are going to learn some important concepts related to circle. Some theorems and terms what we are going to see today, right? There are three basic terms and theorems is what we are going to see today. The first to start off with, inscribed angle theorem. Let's see the first one, inscribed angle theorem. Inscribed angle theorem. Now, the very first thing is what we need to know is what exactly the inscribed angle is all about. My students need to know what exactly inscribed angle is. So let's see first of all what inscribed angle is. Now for that, if we just say that this is nothing but the circle so formed, say this is the circle so formed, and the angle is formed on the circumference of the circle. The angle is angle ABC. Can we see over here, there is one angle so formed on the circumference of the circle, that is angle ABC. This angle ABC is termed as an inscribed angle. I reiterate myself, what exactly an inscribed angle is? The inscribed angle is nothing but angle so formed on the circumference of the circle is termed as an inscribed angle. Over here, angle ABC is an inscribed angle. Angle ABC is an inscribed angle. Coming to the next point, can we see that this particular angle cuts the circle? The circle has been cut over here. Let me name this point as point X. Then this circle is cutting it, or rather intercepting this particular arc. Thus, arc AXC is termed as an intercepted arc. Arc AXC is termed as an intercepted arc. So what are the two terms what we have studied up till now? The two terms what we have studied up till now is nothing but the inscribed angle and the intercepted arc. Over here, the angle which is forming on the circumference of the circle, on the periphery of the circle, is termed as an inscribed angle. So angle ABC is an inscribed angle, and the arc AXC is an intercepted arc. Now what exactly this inscribed angle theorem is? I from my side will suggest and say IAT, inscribed angle theorem as IAT. Now what this particular theorem has to say, let's say what the statement is. The statement says inscribed angle is half the intercepted arc, is half the intercepted arc. Over here, angle ABC is an inscribed angle and arc AXC is an inscribed intercepted arc. Then as per this particular theorem, what we say is measure angle ABC is half measure arc AXC. Measure angle ABC is half measure arc AXC. Now let me just say this as equation number 1. I require this particular stuff in the later part, and that's the reason I've just given it as equation number 1. Let's see an example based on this, how this particular thing works out. If somebody has to tell me that what exactly the arc AXC is all about, and somebody has to give me the figure as 80, that measure arc AXC is 80 degree. Now based on the inscribed angle theorem, which is IAT, the angle so formed over here is half of it. So the answer is going to be 40 degree. The answer so formed is going to be 40 degree. That by which you can say the inscribed angle is half the intercepted arc. Absolutely true as far as vice versa is concerned. If somebody has to tell me the inscribed angle, say somebody has to give me this inscribed angle, for that matter, let this be 35 degree. Then over here we can clearly see that twice the inscribed angle is going to be the intercepted arc. The value of the arc so formed is going to be 70 degree. The value of the arc so formed is going to be 70 degree. This is the very first concept what we have learnt in circle, the inscribed angle and the intercepted arc, and the relation between inscribed angle and the intercepted arc, which states the inscribed angle is half the intercepted arc. Now what we are going to focus is the next theorem or the next concept, that is nothing but the tangent secant theorem. The tangent secant theorem. I hope my student knows what exactly a tangent and a secant is. We proceed with this particular theorem, what exactly this theorem has to say. But before that, let's learn what is the angle so formed between a tangent by a tangent and a secant. So say this is line L. So say this is line L, intersecting the circle in point A. Intersecting the circle in point A. So I say as of now that line L is tangent at point A. There lies a secant. There lies a secant. The secant is, say, line M is a secant. Line M is a secant. Cutting the circle, intersecting the circle at two distinct points. This is, say, point C. Can we see an angle so formed between these two lines? That is angle CAQ. This is the angle CAQ. Angle CAQ is the angle so formed by a tangent and a secant. If we try and understand the same concept what we learned over here is nothing but the intercepted arc. Over here also there is an intercepted arc. Say this is X. Say this is X. Then this is going to be arc AXE, which is going to be an intercepted arc. Absolutely on a parallel line. How I stated inscribed angle theorem is IAT. I from my side say this as TST, tangent secant theorem. Now what does tangent secant theorem has to say? Tangent secant theorem also says the same. The angle so formed is half the intercepted arc. So what is the application? The application over here is going to be measure angle. Measure angle CAQ. Measure angle CAQ is half measure arc. Is half measure arc AXC. Again, let's take an illustration. If somebody has to give me this value is say 100 degree, then the answer so formed, this is going to be 50 degree as stated. The angle is half the arc value is 100. That's the reason we have the angle so formed is 50 degree. Vice versa is absolutely the same. If somebody has to tell me this angle as 60 degree, then this arc is going to be twice of it. It happens to be 60 degree. If this happens to be 30, this happens to be 60. Now what we do is, we try to combine, merge, club both of them, and let's see what a new theorem comes into existence. Yes indeed, we have a totally new concept if we club them together. My students, you just need to focus and visualize. Try and visualize both the concept and you might get it. What I do is, I sum up IAT and TST. So it's again from my side. There is nothing geometrical in this. It's only from my side. If I sum up, we come with a new concept. And the new concept is the third part. And the new concept is the third part. And the third part is termed as angles formed in alternate segment. Angles formed in alternate segments. Now, again a shortcut from my side, I simply say this as a FAS. I simply say this as a FAS. Angles formed in alternate segment. Let's club both the figure. Let's merge both the figure. As I have given over here this as equation number 1, let me say this as equation number 2. Club both the figures and what do we get? We get something figure of this nature. We get figure of this nature whereby which, I'll just draw once again the circle to be on a accurate side. Now this is nothing but a circle. If I draw this particular figure, what am I going to get is this line L. I'm drawing right now this particular figure. This is line L, this is point A, this is X, this is point C. I would like to make this inscribed angle absolutely over here. So this is nothing but the inscribed angle as we stated. So this is the inscribed angle. This is nothing but the inscribed angle, angle ABC. This is angle ABC. This is the inscribed angle over here, and this is the tangent secant angle which is being formed. This is the tangent secant angle so formed over here. Now, if we have to say in geometric sense, what is equation number 1 trying to say? Equation number 1 tries to say that angle ABC is half measure arc AXC. What is TST trying to say? Measure angle CAQ is half measure arc AXC. If you just look at the right hand side of both the equations, what do you see? If you happen to see the right hand side of both the equations, it's half measure arc AXC, half measure arc AXC. Both the right hand sides happens to be the same. So a new concept comes in your way. The left hand side has to be the same. Thus we get a new theorem, angles found in alternate segment, and we get measure angle ABC is equals to measure angle CAQ. Measure angle ABC, you can say this is measure angle ABC, this is measure angle CAQ. Let us name this as Q. So this is measure angle CAQ, and mind you, these are nothing but angles which are formed in alternate segments. These are nothing but angles which are formed in alternate segments, and we say that angles formed in alternate segments are always congruent, they are always equal. So now we have measure angle ABC is equals to measure angle CAQ, and I from my side say this is nothing but an AFAS. So what's an AFAS? AFAS is nothing but angles formed in an alternate segment. And how we have derived that particular angles found in an alternate segment? We have understood inscribed angle theorem, IAT. We have understood what is TST. We have got the relation between IAT and TST. I from my side, in order to obtain this particular stuff, I said that let's them club together, let's merge together, and we obtain a new diagram. And if we try and visualize it, it's absolutely a merging. We get this two figure, or merging this two figure, we get this particular figure, and we get the relation between the inscribed angle and the tangent secant angle. We get the relation between inscribed angle and the tangent secant angle, and the relation is nothing but the inscribed angle and the tangent secant angle is congruent. These angles are termed as angles formed in alternate segment. From my side, I do say this as AFAS. Now, this picture is going to get much and more clear when we do one simple sum based on this, that is AFAS. You will understand much and more how AFAS works out.